Hello guys, welcome back to DSA playlist by 2am Coder. If you are first time in this channel, we are covering sorting technique in this playlist, and in this video we are going to talk about merge sort, which is one of the most efficient sorting technique and it is very easy to understand as well. So without further ado, let's get started. So guys, let's consider this is the array we have, and in this array we are going to apply merge sort. So main fundamental of merge sort is you need to divide the array and you need to merge them back in such a way that it will be in a sorted format. So when you are merging, you need to place the numbers in ascending or descending order. That we will see in the algorithm. So first we will write the steps what we are going to follow in order to sort the array in merge sort technique. So basically you need to divide the array. So you can divide it either 50-50% or you can divide it in 30-70 or you can divide it in 40 and 60%. So the best way is to divide the array in 50-50 parts. That means we will find the mid position and from the mid we will divide the array in two equal parts and we will try to merge them back. So first step, we need to find the mid value and we need to divide the array into equal part. So let's quickly write the steps here. Step 1, divide the array from the mid. So how we will do that? So basically to find the mid value, we will do s plus e. So s is nothing but the starting point, e is nothing but the end point. So this is how we will find the mid value and we will divide the array into equal parts. So we will have two array. You can say left array will start from s to mid and right array will start from mid plus 1 to end point. So this will be the index point when you divide the array into equal part. So basically we will find the mid value and from the mid we will consider the left array and the right array. So the starting point of the left array will be s and end point will become mid itself, and the right portion will have the starting point as mid plus 1 and end will be e only. Okay, so let's quickly find the mid value here and we will divide the array. So here you can see start is 0, end is 6. 6 divided by 2 is nothing but 3. So this is the midpoint here, and as I said, left array will become start to mid. So this is my left array and right array will become mid plus 1 to end, and this is the right array. Okay, now we need to divide this. Now you can see we have divided the array in two parts. Now let's move to the step 2. Step 2. So once we have divided the array in two parts, we have to keep dividing them until we find only one element left in the array, or you can say when s is equal to the e. So we need to do this recursively. So for that you should know recursion as well. If you don't know, we will cover the recursion topic as well in the next upcoming videos. So step 2 is nothing but keep dividing the left and right array recursively until s is equals to e, or you can say if s is greater than or equal to e. So this will be the condition when we have to stop, because at that point of time you will have only one element left in the array after dividing, or you can say only one element left in the array. So when you say only one element left in the array, that means it is hypothetically. We are not dividing the array actually, so we will just change the start and end point in the array so that it will keep shrinking and you will have s is equals to e. So at that point of time you can say there is only one element left. So that we have already seen quick sort technique in our previous video. So that is same here. Since we have to divide the array recursively, so in recursion you know when you do any operation recursively, first left portion will complete and then only we will go to the right portion. So this is how recursion actually works. So let's keep dividing the left portion and then we will see the right portion. So as you can see, this is the left array and I will place it here. Okay, so this is the left portion, and again, as I said, step we have to keep dividing this. So for dividing, again we need the mid value here. So mid value is nothing but start plus end divided by 2. So here mid will become 0 plus 3 divided by 2, which is 1. So this is the mid here, and again we will have left and right array. So this is the left and right array, and again we need to keep dividing the left array and then right array. So this is the left array. Let me place it here. Now again you need to divide this array from the mid. So again we have the mid value 0 plus 1 divided by 2 is nothing but 0. So this is mid in this case. This is the left array and this is the right array. Now again we need to place them here. So let's place it. Okay, so as you can see, I have done with the left array. So all the left portion is completed now. So let's go back to the previous state, that means 5. So now we will divide this. So right side of this stack is completed. Now this is also divided in 2 parts, and when you go back from here to the previous stack, this array is completed, and now we will divide the right array from here. So let's separate it from here. So guys, as you can see, this is the right portion of this array. Now again we need to divide this, right? So we need mid value. So mid is nothing but 2 plus 3 divided by 2, which is nothing but 2 only. 2 plus 3 is equals to 5, and 5 divided by 2 is 2. So here in this case, the mid value will be 2. So let's divide this. So this is our first array and this is the second array. So when you say this is the first and second, so we need to place them separately from here, right? So let me place it separately. So guys, as you can see, this whole left portion is now divided until we have S is equals to E. That means there is only one element left in this left portion. So this is divided completely. Now the same thing we need to follow in the right side as well. So we need to keep dividing the right array as well. So let me place this particular portion separately from this array. Okay guys, so this is the right portion of the array. Now again we need to divide this array from the mid. So mid value is nothing but 4 plus 6 divided by 2, which is 5. So mid is 5 here. Let me place the mid value. So this is the mid value. So again we need left and right array. So left array is nothing but this portion and right array is this portion. Now again, when you divide them, you first keep dividing the left part and then you move to the right portion. So let me place the left part separately from here. Okay, so this is the left portion of the array. Now again, we need to find the mid value here again to keep dividing it in the next step. So mid is nothing but 4 here because 4 plus 5 is 9 and 9 divided by 2 is 4. This is the mid, and here the left portion is this, and this is the right portion of the array. And again we need to separate it, right? So let me separate them. So as you can see, we have divided the left portion here, and let's go back to the previous stack. So this is divided, and when we go back here, we have the right portion here as well. So let me separate it out from here to the next step. So since there is only one element left, so we cannot divide this part further. So as you can see guys, we have divided the array till the end when there is only one element left. That means S is equals to E. Now we need to merge them. Okay, so when we are merging, so we need to merge them from the left side to the right side. So this is how recursion works. So basically first it will divide the array in left part. That means from here it will go here, and then it will go here, and then it will go here. So there is only one element left. It will go back to the previous stack and it will again go to the right side. Here only one element left. Now it will merge these two parts. That means 0 index and 1 index. So how it will merge? So that is our third step. Step 3 is merge the left and right array in ascending or descending order. So it depends. You need ascending sorted array or descending sorted array. Based on that, we will add the condition and we will keep merging these values. Okay, now from here, so as you know, we need to merge them. So let me remove this completely from here. Now guys, as you can see, I have removed everything from these arrays because we have divided successfully till the end, right? So now we have to merge them and we need to fill this array after merging. So how we will do that, we will see now. So for that I need one pointer in left array and one pointer in the right array and one pointer in the empty array. Initially there is only one element in the left side and in the right side as well. So now we need to merge these two array, and when you merge them we will see whichever is less, and whatever is less will come first here. So 2 is less, so we will place 2 here. Now we have placed 2 in the 0th index. We will move it to the next index, so there is nothing. So loop has broken. So there is only one element left in the one side. So whatever has left in the next array, we will place it in the next position. So simply we will move this to the next index, and whatever we will have, and we will place it in the next index. So as you can see, this portion is now sorted. So let me remove this from here. Okay, let me remove this as well because this is completed. This will go to the next index and this loop will break. Now when you go to the right side, there is nothing, so this will break further. So we have already divided this, and now we need to merge them because there is only one element left. So when you merge them, again we will need 3 pointers, which will come in the left array, which will come in the right side array, and which the third one will come in the result array first index. Okay, so when you check these two array value, whichever is less will come in the first position. So 7 is less, it will come in the first position. Let me increase the size. So after adding it in the correct position, we will move the index. So as you can see, it is now out of the loop and this loop has broken. Now whatever has left in the other side of array, we will directly place them in the next index. So it will move to the next index, and whatever has left, we will directly place them. And this will again move to the next index, and there is no element left, so it will break. Now as you can see, this particular portion is sorted now. Let's remove this. Now we have left array and right array again. Now we need to merge them and we need to make another array. For that I need 3 indexes point again. Now we need to check the index 0 and index 2 value. Whichever is less will come in this pointer position. So as you can see, we will place 2 here directly, and let me increase the size. Since it was from this pointer, it will move to the next index, and this will also move to the next index. Now we will check index 1 with index 2. So whichever is less will come in this pointer position. So here you can see 5 is less, so it will come here. And as soon as we place it in the correct order, we will move the index to the next position. So there is nothing left, so it will break the loop, and this will also move to the next index. And whatever the left from the pointer position, we will keep adding in the remaining empty portion. So here you can see the pointer is at index value 2. So we will directly place the index 2 value to the result array, and we will move the index to the next position. And again, this will also move to the next position. And here you can see index 3 value will jump to the result array here, and this will again increase the pointer, and loop will break here again, and this will also change to the next index because there is no element left here, and this will also break. Sorry, this is nothing but 7. So as you can see, this portion is now merged and now it is sorted. This particular portion is sorted. Now we can delete this from here. Now let's go to the right side portion. So there is nothing, so we need to merge them. Again we need 3 pointer. First it will go here, second here, third here. So we will directly check index 4 with index 5 value. Whichever is less will come in the first position. Here it will come as 6. Okay, so as soon as we place the 6 in the correct position, we will increase the index value from where we have taken, and since there is no element left, we will remove this, and this will increment to the next index. Now whatever we have left in the other array, we will directly place it in the resulted array pointer position. So we will place 15 here directly, and this will again move to the next index, and there is no item left, so we can break this. So as you can see, this particular portion is now sorted. We will remove this. Now we need to merge these two. Again we will take 3 pointer first here, second here, and third will go to the starting of the result array. Now again we need to check the left pointer with the right pointer. Whichever is less will come in the resultant array pointer position. So here 6 is lesser than 9, so it will come here. As soon as we found that left side is the lesser, we will increment the left index value, and we will also increase the resultant array index value. Now we will check index 5 with index 6. Whichever is less will come here. So here the lesser is index 6 value, which is 9. We will place 9 here. So as soon as you place 9, you know we need to increment the index here. So there is no element left, so we will remove this, and this will move to the next index. As you have come out of this loop, whatever has left in the other array, we will directly place it, and this will go to the next index and no element present. We will remove this as well. So as you can see, this particular portion is now sorted. Now at the end we need to merge these two arrays. So let's place 3 pointer again, start of both the array and start of the resulting array. So this is nothing but start of the left array, and this is the start of the right array, and this is the start of the resultant array. Now again we need to check these 2 pointer. Whichever is less, place the resultant value here. Lesser value is 2. We will place 2 here. Now as soon as you place 2 here, we will increase pointer to the next index, and this will also move to the next index. Now again we will check index 1 with index 4. 5 is less than 6, so we will place 5 here, and this will move to the next index, and this will also move to the next index. Now we will check index 2 with index 4. Now index 4 value is less, so we will place it here, which is 6, and we will move this to the next index. So in this case we will not move this value because we have taken value from this index, and this will also move to the next index. Now we will check index 2 with index 5. So as you can see, index 2 value is less, so we will place it here. 7 will come here, and this will move to the next index, and this will also move to the next index. Now we will check index 3 with index 5. So index 5 value is less, so we'll place it here, which is 9. So as soon as you place it there, we need to increment the index value, and here also we will have to increment it. Now we will check index 3 with index 6. So index 3 value is lesser, we will place 12 here. So as soon as you place 12 here, we need to increment the value. So as you can see, the pointer value has become more than end value, or you can say it has exceeded the limit. So we have to eliminate this, and we have to increment this as well. So whatever has left in the other array, we will simply place it in the upcoming indexes. So there is only one element, so we'll place it in 5, and we will move the index to the next element. There is no element left, so this is also eliminated, and this will also eliminated because there is no element left. So we will remove this from here because now it's merged, and now you can say this array is sorted now. So I hope you have understood the core concept of merge sort, where you have to keep dividing the array recursively, and when you do recursion, you keep dividing them, you will have only one element left, and at that point of time you need to stop the division and need to start the merging of those left and right side array. So we will see that in the algorithm how we will do this. So let me place the old value here again, so that again we will try to understand with the implementation. So guys, this was the initial value. So now we are going to implement this logic, and since we have the steps written here, we will follow the same. So let me create one method here. So this will take parameter as array, int start index, end index. Okay, so this is the first method we will have. So what is the first step? We need to find the mid value. So let's quickly find the mid value. Now what we are saying in the next step, keep dividing the left and right array recursively until we will have s is greater than or equal to e. That means there is only one element left in the left side, and there is only one element left in the right side as well. So we need to keep dividing this. So since you know we have written this division, we are dividing with mid, right? So if we call this method again, so again it will divide the array from the mid position, right? So from the left side and right side, we can consider the mid value as the end point of left side array and mid plus 1 as the start point of the right side array. So this is how we will do this. Merge sort, we will pass same array. We are not creating new object of the array, but we have to change the start and end index. So for the left side, so index value here is 0 to 6 is 3. So this is the midpoint, and this will be the left array and this will be the right array. Okay, so in that case you can see start is nothing but the same value. This will be the start, and end has changed for the left side array. So end has changed for the left array, so it has become 3 now, which is nothing but the mid value. And again for the right array, we will call the same method. Here the start has become mid plus 1 and end is same as the e value. Okay, so with this step, what we are saying, execution will come here. You will have the complete array and then start as 0 and as 6, and then you will have the mid value as 3. And again you are saying merge sort. We are calling the same method again. So again what it will do, it will take the start 0, mid as end. Now this has become your one array portion, and again it will call the mid, this particular method again. Now again you will find the mid value, which is nothing but 1 here. In that case what it will do, it will again create a left array, and for the right array again it will be mid plus 1, which is mid plus 1, which is nothing but 1 plus 1 2, and then end. So this will be your next division of left and right side array. Okay, again in the left array you're calling merge sort again. So this will divide the array further into equal part. So this will become your left array and 5 will become your right side array. Okay, so this is how recursion works. Actually you will keep dividing the array, and hypothetically you are not dividing, but hypothetically you are dividing and you are changing the start and end value. It will keep happening until you have s is equals to 0. So in that case s should be always less than e. As soon as s become equal to the e, you will break the loop. So as soon as you will call this method again and again and again, it will keep dividing, and at the end when s will become equal to the e, this will not come inside this block and it will return something. So this merge sort will return something, and this merge sort will also return something at the end. Okay, so let me demonstrate this in one flow. So from the left array, again you need to divide this, right? So what you will do, you will divide this in next two position. Okay, so this will be your left array, which you will call from this merge sort. Okay, so this merge sort will call this method again. So s is 0 and is 3. So s is less than e here, and again it will find the mid value. Mid is nothing but 1, and what it will do, it will again call the merge sort, this method again with array. S will become s equals to the s, which is 0 again, and end will become the mid value, which is 1. Okay, so this is the left side of this array. Now again when you come here, it will again call this, again it will check if s is less than e, again it is less than e only, and then again it will find the mid value, and again it will try to divide this. So this is the left array again, and what it will do, it will find the mid value, which is again 0 here. It will call the merge sort again with s, which is 0, and mid here is. So this is the left portion of the previous array, and again when you call this merge sort with this indexes, again it will find the mid value. So mid value is nothing but 0 here. So 0 plus 1 divided by 2 is 0, and array start is 0, mid is also 0. So this will be your left array again, and it will call the merge sort again using this index value. So let me place it here. So as you can see, when merge sort will call again using when s is 0 and mid is also 0, it will come here, and when s has become equal to the e, it will not enter in this block and it will return from here, it will come out. So here, so when merge sort will call again recursively using s as 0 and mid as 0, s is equal to the e, so this will not execute this particular block, and this will end this function, or you can say this method method stack. This will end the method execution and this will go to the previous method stack. So it will return something, or because we are not returning anything, but it will come here and it will try to divide the next right portion of the array, which is mid plus 1 and e, which is nothing but 5. Again it will divide here, and since there is only one element, let me place it here. So as you can see, this array, when you call merge sort after returning merge sort in the previous stack, it will come here and it will take mid plus 1 as starting, which is 1, and end, which is again 1 here, and it will call this merge sort again. So here also you can see s and e is equal, which is 1. Okay, so this will not execute this block and this will complete the method execution, and it will come here again. So when you will come here and try to execute next line when there is only one element left. So in this case, what we need to do, when you have only one element left in the left side and in the right side, this will go to the previous method stack, right? Because this method execution will complete. So without completing this method execution, we need to merge these two. So in this case, you will have starting as 0, end as 1, and mid as 0 again. Okay, so we need to merge. So when you merge, you need to pass the array value and you need to pass starting, which is 0 in this case. So we are merging these two array. Okay, so we will merge these two array and we will place it here. Okay, so this will go back to the previous method stack. So we need to pass starting value and we also need mid, and that we will see why we need mid as well, and we will need end point as well. Let me reduce the spaces. Okay, so this method code is completed. So how we will merge? Again, we will create one method. Okay, so we need these three parameters. Okay, so this is the resultant array, right? So for that, let me create one temporary array of size. So here we need to mention the size. So as you can see, size, how we can mention the size? So it's nothing but end minus start plus 1. This will create your temporary variable of size 2 in this case. When you come here, it will again change the end and starting value, and it will create the temporary value with some size accordingly. And in our previous explanation, we saw we need 3 pointers, right? First will come here, second will come here, and third will come here. So let me create, so this we will consider as left, start point of the left array, which is nothing but s. This we will consider as the right, which is start point of the right array, which is nothing but your mid plus 1. So that's why we need mid value here, because mid plus 1 will become the starting point of the right array. Okay, always, because here also you can see mid is 3 and starting point of next array is nothing but mid plus 1. Okay, and we need another pointer which we can say as j. Initially it will be 0. So 0 is 0. So this j pointer will be used to place the value in temporary variable. So we will iterate temporary using j index. Now here we need to check the left side array with the right side array, and whichever will have the less value, we need to place them here in the resultant index, which is in the temporary array. Okay, so what I will do here, we will write one condition: if array of left, so this is nothing but the left pointer, right? If it is less than or equal to the right array, then in that case we will place So here we are placing j value is 0, and in 0th index we will place the left side array if it is less than the right side array or equal to the right side array. If it is not, then we need to place temp j, right index of the array. Okay, now when you place left, so you remember we need to increment the pointer as well. So here we will increment the left pointer If it is right, then we need to increment the right pointer, and in both the cases we will increment the j pointer. So that's why I have kept it outside the condition, because in the both condition we need to increment j value to the next index. So this will execute only once, but we need to keep executing when there is multiple item, right? So when there is multiple item, so for that we need to write one while loop. While now the condition will be something like this: when left, which is left index, if it is less than equal to the mid. So mid is nothing but the end point of the left array. Okay, so we will check from the start to the mid, that means the end point of the left array. And when right is less than equal to the e, so e is nothing but end of the right array, and right will nothing but initially it will be the starting point of the right side array. Okay, so we will keep incrementing. So as you can see, we are incrementing the right value and the left value, and we will keep checking until when this condition will satisfy. That means when left will reach to the end of left array and right will reach to the end of the right array. Until that point only we will execute this particular condition. So here you can see left is equal to the mid, that means 0, and left is less than the right value, right is 1. We will place temp j is 0. We need one temporary variable, so this is the temporary variable, and now we will start placing the value in this temporary variable. So initially left will come here because it is lesser than the right value, so 2 will come here, and then left value will increase to the next index. Okay, now as you can see, left has increased and j value is also increased. So j value is in the 0 position and j value has increased to the 1 index. This condition will not satisfy because now left has become 1 and mid value is 0. This will come out of the loop, but still we have value in the right side, right? So for that we will directly place the right side array value to the temporary value directly. So j value is 1. Again we will write while when right is less than equal to the end. What we will do, we will directly place leftover value from other array to the resultant array. Now when you write the logic for leftover arrays, you don't need to check this condition. That means if it is less than the right side array or greater than the right side array, because there is only one array left in this condition, so we will directly place it in the resultant array. So what we will do, we will simply write it like this, and we will place right array index value to the temporary array. We will increment the j value. We will increment the right index as well. Now let's assume there is another case when you might have incremented this value and this is in its actual position. Now you have leftover values from the left array, so that condition also we need to write. Okay, so here we will say left if it is less than equal to the end point. So what is the end point for the left array? It's nothing but a mid value. We will place temporary j from array left. We will place left value directly to the temporary variable. J value will increase by 1, and here we will write left plus plus. So whatever leftover value will be there in the left array will be placed in the temporary variable directly, and this will place the leftover value from the right array to the resultant array directly. Now when you will come out of this loop, when this condition will place it here and this was here, so when this loop will break, it will come here. It will check right is less than equal to end. Yes, it is equal to the end. It will come here. What is the array? Right, it's 5. It will place it in the temporary j value, and j is 1. It will place here. Increase the value of j. J has increased, and increase the value of right as well. When you increase the value of right, you can see now right has the value which is greater than end, so this loop will break. And left, this is already completed, so this will not execute. So now you can see you have this temporary variable as sorted array. Now you need to place this in this array, in actual array. Okay, so for that again we will write one loop. I will be from 0 and this will go till temporary dot length I plus plus. So we are looping through based on this temporary index array. Okay, because we have only two elements here and your array will also occupy with two elements. So your final array will also occupy only two elements. So that's why we can check with the temporary array size. Now here what we'll do, we will copy this temporary value to the actual array. Now from where we need to start putting the value. So as you can see, we have taken this value start s and we have not changed this till here. We are only changing left and right index. We are not changing s and e. So here we can say s is the starting point of array where we have to start putting the value from the temporary array. And temp will have I, and here we need to increment the s value. Now in this way what it will do, initially from temporary I, that means from 0, what is the s value here? It is also 0 here. It will place 2 directly to the 0. Increase the value of s. So we are also incrementing the value of s will come here, and in the loop we are incrementing the value of I, and I will become 1, and we will place value 5 in this index. And this will come here, and once it will come here, this will also break the loop because I value will be equal to the size in this case. Okay, so this particular section will be sorted. Same thing when you return from here. So when you have this sorted array here, that means you called this merge method, right? And it has merged this particular portion, and it will come here, and then it will execute the previous merge sort method, okay, which is available in the method stack. This means it will come here and it will take the value from the right array of this array, and again it will merge them from the right side, and again this value 2 and 5 and this 7 and 12 will merge together and it will become 2, 5, 7, 12. And similarly this right side array will be divided in two parts and we will merge them recursively with the same logic. Okay guys, so let's try to code this in IDE, and I have placed this, I have come to this previous state when we have divided this and we have merged this to the final sorted array. So let's code this in IDE and we will see. Let's create one class called merge sort. Okay, so let's print this array. So currently it is not sorted. Let's create one method called merge sort. So this will take 3 parameters as array, starting index and end index. Now we need to divide this array, right? So for dividing the array we need mid value. It is equals to s plus e divided by 2. Now once we have the mid value, we have to keep dividing the left and right array recursively until we find s is equals to e. So let's call the merge sort recursively, and we need to find the left array. So for the left array, s will be the start point and mid will be the end point, and for the right side array, mid plus 1 will be the start point and e will be the end point. And we have to call this array, and we have to call this method recursively until s is less than e. As soon as s has become equal to the e value, we will not execute this. In that case, what will happen? It will keep dividing the array, left array. It will go to the left again. It will have only one value. So as soon as it has one value, s will become equal to the I. It will return something and it will go to the right side. And in the right side also, it will have only one value left at the end. Then also it will return something. That means it will come back from this method stack to the previous stack, and this 2 will come here and 5. In that condition we need to merge them. Merge array. We will pass array, we will pass starting point in this stack. So in this stack, starting is 0, end is 1. Okay, we will need mid value, we will need end value. So if you remember, we need mid value to understand where is the starting point of the next array. So this method code is completed. Let's create one more method, merge array. This will take array, starting index, mid, end index. Now we need to merge them. So let's consider this portion. So we need 3-pointer. Let's create 3-pointer here. It will be here. It will be here initially. And these two array, this is the left and this is the right array. Okay, so let's make one pointer called left. So this is the starting point of the left array, which is nothing but S, and starting of right array is nothing but it's nothing but right, and this will be nothing but mid plus 1. So this is the mid. Okay, here in this case you can see we have divided from mid, right? So right side starting point is nothing but mid plus 1. So this is mid plus 1 as the right array starting point, and we need one temporary variable starting point which we can consider as j equal to 0. We need one temporary array as well. So this is how we initialize the array, and we have to give the size here. So this is the size. So the resultant array size is 4. So here you can see 3 minus 0 plus 1 is equals to 4 only. So 3 is nothing but E, 0 is nothing but S. E minus S plus 1. So this is our temporary variable and the size of the temporary variable. So I think this is all we need, and now we need to check left and right side pointer position. If array of left, if it is equal to or less than array of right side, if it is equal to or less than the right side, in that case what we will do, we will put this value to the temporary variable. Temporary, initially j is the index value, and we will put array left because it has the lesser value, and we will increment the left value plus 1. So here it will be incremented by 1. It will come here, and we will also increment the value of j. Else when right value have the least, when right array has the lesser value. Okay, so in that case we will put value from right array into the temporary array, increment the value of right index, and here also we need to increment the value of j. So I'll put it outside the condition, and we have to do this for each index, okay, until any of the array will exceed its pointer limit. So when left is less than or equal to mid, and that means when we traverse each index in the left array, and if right is less than equal to the end, that means when we traverse each element in the right array. So when any of the left or right array has completed its traversal, we will come out of this while loop, because whatever value has left now, either in the left side array or in the right side array, we can directly put it into the temporary variable, temporary array directly. So you can see here array starting index, mid, end index. Now we need to merge them. So let's consider this portion. So we need 3-pointer. Let's create 3-pointer here. It will be here. It will be here initially. And these two array, this is the left and this is the right array. Okay, so let's make one pointer called left. So this is the starting point of the left array, which is nothing but S, and starting of right array is nothing but it's nothing but right, and this will be nothing but mid plus 1. So this is the mid. Okay, here in this case you can see we have divided from mid, right? So right side starting point is nothing but mid plus 1. So this is mid plus 1 as the right array starting point, and we need one temporary variable starting point which we can consider as j equal to 0. We need one temporary array as well. So this is how we initialize the array, and we have to give the size here. So this is the size. So the resultant array size is 4. So here you can see 3 minus 0 plus 1 is equals to 4 only. So 3 is nothing but E, 0 is nothing but S. E minus S plus 1. So this is our temporary variable and the size of the temporary variable. So I think this is all we need, and now we need to check left and right side pointer position. If array of left, if it is equal to or less than array of right side. If it is equal to or less than the right side, in that case what we will do, we will put this value to the temporary variable. Temporary, initially j is the index value, and we will put array left because it has the lesser value, and we will increment the left value +1. So here it will be incremented by 1. It will come here, and we will also increment the value of j. Else when right array has the lesser value. Okay, so in that case we will put value from right array into the temporary array. Increment the value of right index, and here also we need to increment the value of j, so I'll put it outside the condition, and we have to do this continuously for each index, okay, until any of the array will exceed its pointer limit. So when left is less than or equal to mid, that means when we traverse each index in the left array, and if right is less than equal to the end, that means when we traverse each element in the right array. So when any of the left or right array has completed its traversal, we will come out of this while loop, because whatever value has left now, either in the left side array or in the right side array, we can directly put it into the temporary array directly. So you can see here we have increased the value of left here, right? And in the next iteration, left is less than or equal to mid, yes. Right is also less than equal to end, yes. And again we will check left with the right. So as you can see here, left has the lesser value than the right, so we will move this 5 to the resultant index. This will also move to the next index, and as soon as we move this to the resultant, that means in the temporary, we will increment the value of left, and value of j will also move to the next index. So when you have incremented the value of left, this will come out of the loop. This loop will break, and you can see this is sorted till here, and this is itself a sorted array, so we can directly place it in the next upcoming indexes, right? Because this is sorted from this portion, and we don't need to sort it because it's a sorted array. We can directly place it in the upcoming indexes of the temporary variable. So that we will do similarly how we have done here. When left is less than equal to the mid, when values are left in the left array, increment the value of left, increment the value of j. Similarly, we will do this for right array when the elements are left in the right array. So in that case, we will the values from right array directly into the temporary array j++. So in this way, we will put complete left and right array into the temporary variable. So this is the temporary variable, and we need value in the actual array, right? So we can copy this temporary array into the right. So we can copy this temporary array into the actual array, and starting point of actual array is nothing but s, and we have not changed the value of s till here. I is equals to 0. I will go till temporary dot length because both will have equal size, I++. So we are putting into the actual array value. So we are putting value into the actual array, and starting point is s, and temp from I, and I value will keep incrementing, and we need to increment the value of s here so that it will also move to the next index. So this is how we will place the temporary array value into the actual array. So from here we don't need to return anything because here only we are placing the array into the actual array. We are calling this method here. Again it will execute, it will merge the array from the previous stack, it will merge the array from the previous method stack, and it will do the operation recursively. So let's call this method from here, merge sort array. Starting is nothing but 0, end is nothing but array dot length minus 1. Yeah, that's it. Let's run the code. So as you can see, this is working. So the time complexity of this sorting technique is nothing but n log n. So this is the best case scenario, and worst case scenario is again n square. But it is very easy to understand and it is very efficient. So whenever you get any question in interview to sort the array in the most efficient way, you should follow the merge sort technique because it is easy to remember as well. So that's all about the merge sort. I hope you have liked the video. If you like what you saw, just hit the like button, share with your friend, leave your comments in the comment section. I'll see you in the next video. Till then, bye bye, take care.